welcome back. We forgot all about I to the 23rd. Poor I to the 23rd. Let's do that on the next page. This is actually a really easy problem. So let me show you. All right, so I to the 23rd. I to the first, of course, it's just I, right? Anything to the first power is just itself. I squared, remember back here, is -1. I cubed, well, that would be the same as I squared times I. I squared is -1, and that would be -1 times I. That's -I. I to the fourth, well, I could do I cubed times I, but I think it's easier to do I squared times I squared. I squared is -1, so -1 times -1 is +1. If I took -1 times, if I took I times -I, I would have gotten the same thing, right? Because I squared is -1, and -1 times -1 would be 1. But I think it's just easier with I squared times I squared. I to the fifth, well, that would be I to the fourth. Actually, yeah, I'll write it there. I to the fourth times I. I to the fourth was just 1, so that's 1 times I, and that's just I. I to the sixth, can you guess what it's going to be? Well, I to the sixth would be the same as I to the fifth times I to the first. So I to the fifth is I to the first is I. So I times I, that's I squared. And what's I squared? -1. I think there's a pattern here. I to the seventh, well, that would be equal to I to the fifth, I to the sixth times I. Well, I to the sixth is -1, and so that's just going to give us a -I. And I'm sure everyone has figured out how I to the eighth is going to be. By the way, that's just I to the fourth times I to the fourth. Or I could take I to the seventh times I to the first, or I to the sixth times I squared, or I to the fifth times I cubed. Either way, it's going to be I -1, -I 1. I -1, negative I, sorry, that dot is kind of small, -I 1. And matter of fact, it's going to just keep repeating, so that every fourth term in the sequence is going to be 1. So that means that I to the fourth is 1, and I to the eighth is 1, and I to the 12th is 1, and I to the 16th is 1, and I to the 20th is 1. And that means I to the 23rd would just be 1 times I to the third. Let's just write it down as I to the 20th times I to the third, which is 1, and I to the third is just -I, so that's going to be -I. All right, so that's pretty easy. You could figure out I to the 5,002 power. Right? I could count, by 4s to 23. I ain't counting by 4s to 5,002. Right? But if I take 5,000 and divide that by 4, right? It's going to go in once. It's going to go in twice. It's going to go in 1,250 times, but we want 5,002. I knew that was an even, I knew 5,000 was a multiple of 4. We want 5,002, so there would be a remainder of 2, which means that I to the 5,002 is going to go through the sequence 2, it's going to go 2 more terms, right? So I to the 5,000, the one that went in evenly, was 1,250. that would have been 1, right? The next term, the 5,000 in first term would have been I, and the 5,000 in second term, -1, right? So you can figure out I to any power simply by dividing by 4. Whatever the remainder is, that tells you if there's a remainder of 0, it's 1. If it's a remainder of 1, it's I. If there's a remainder of 2, it's -1. And if there's a remainder of 3, it's -I. And that's all there can be, right? It's divided by 4. All right, so we finished up our last problem. Thanks for watching, and bye for now.